So lab 4, implementing IPv6 networks and solutions. The objectives to configure basic IPv6 addressing. Throughout the course, we've been dealing with IPv4 addresses. So now we are going to see how to configure IPv6 addresses on both physical interfaces and also loopback interfaces. Also how to configure OSPF version 3. This is the routing protocol that operates with IPv6. So OSPF version 3 routing protocol. Also how to configure DHCP v6, the DHCP version that deals with IPv6. And we're also going to verify the results using the display, the IPv6 display commands. So this is the topology that we're going to be dealing with. We have 3 routers. Each of the router, they've been interconnected through a switch or a cloud, whichever, and they have a link local address on the interfaces that are interconnecting them. But they also have a loopback address, which have a public IPv6 address. So the scenario, in line with plans for deployment of solutions for next generation networks, it has been decided that the enterprise network should implement an IPv6 design to the existing infrastructure. So as the administrator, you have been tasked with the job of implementing the addressing scheme and routing for IPv6, as well as providing stateful addressing solution for IPv6. So stateful, we're not going to do Slack, we're going to do a DHCP server. So let's begin by preparing the environment. On step 1, very easy, just changing the routers names. Then we go ahead and do IPv6 configuration on each of the loopback and also physical interfaces. So let's begin. Okay. So that is the topology. So let's rename these routers first. So this is R2 and this is R3. Good. Okay, so after that we create a loopback 0. So interface loopback 0. Then we need to enable IPv6 first. There's something I'm forgetting here. Before we configure an IPv6 address on interfaces, we need to enable it on the system view. But let's just go ahead so that we see the error that it's going to give us. It's actually an advice. So how we configure IPv6 addresses on an interface, first you have to enable IPv6 using the command IPv6 enable. So we do IPv6 enable on loopback 0. Then you go ahead and use the command IPv6 address. IPv6 address. Then you enter the condensed format of that particular address. So here we're having 2001 :1 :A. Then you enter the prefix. The prefix here is 64. So space, then the prefix. So that's how we configure an IPv6 address, like that. So now you see, it tells us, please enable IPv6 function in system view. So we've not enabled IPv6 on system view, but that does not negate the fact that we've configured an IPv6 address on this particular interface. So if we do display this, we can see that indeed that address has been accepted. Well, let's go ahead and enable IPv6 on system view. How to do that? You just type IPv6 on system view. So if you type IPv6 on system view, then you have enabled it. You have enabled it. Okay, so let's go to the interface that is connecting R1 to the other routers. So int gigabit 0/0/0. So the first thing you have to do, again, as a reminder, you have to enable IPv6. So IPv6 enable, then you do IPv6 address. You can do the short form there. Then now we do this link local address. So FE80:1. Then we specify it as a link local. Let me just do a question mark. So link local. So we can either do a prefix or we say it's a link local address. When we say it's a link local address, by default, the prefix is actually 64. So not very different from specifying the prefix. Okay. So IPv6 address FE80:1 link local. So link local by default has a prefix of 64. The first 64 bits represent the network or the subnet. Okay, so once we do that, we can see that the link state changes to up. So we can just do display this to see what we've really done on this interface. So we've enabled IPv6 and we've configured it with a link local address FE80:1. Okay, so we are done with R1. Now we go to R2. So we start by enabling IPv6 on system view. So we type the command IPv6. After that, we go to the interface. Let's first create the loopback interface. So int loopback 0, loopback 0. Then we also enable IPv6 here. So IPv6 enable. Then IPv6 address. Then we give it this address 2:B space. We specify the prefix 64 like that. Then after that, we go to interface G0/0/0. We also enable IPv6. Then we do the address FE80:2. We also specify it as a link local address. So if we do quit and display IP int display IPv6 interface brief. So that is one of the display commands that we can use to display interfaces that have been configured with IPv6 addresses. So we can actually see that this one has been configured with this link local address, and loopback 0 has been configured with this IPv6 address 2001. Okay, so we go ahead and also do the same for R3. So we enable IPv6 on system view by typing IPv6. Then we create the loopback interface 0. We enable IPv6 again on the loopback interface. So IPv6 enable, then IPv6 address FE80:3 link local. So after that, we go to int 0/0/0. We enable IPv6. Then IPv6 address for 0/0/0 is FE80:3. Then we specify it as a link local address. Okay, now you can also type the command display IPv6 interface, then the name of the command, gigabit Ethernet, then the number of that particular interface, the name of the interface, then the number. So if I do display IPv6 int gigabit Ethernet 0/0/0, I should be able to see certain details about that particular IPv6 interface. So this is the command we typed. So you can see the physical state is up, the protocol state is up. We can also see the link local address that we've configured on that particular interface. And we can also see the multicast groups. So anytime you configure an IPv6 address on an interface, automatically it's added to a number of multicast groups. For example, we know that this particular multicast group, we know FF02, the entire range of that address is reserved as IPv6 multicast. 1 is for all nodes, .1, :2 is for all routers. So those are some of the groups, multicast groups, that this particular router has already been added on. Okay, we also know about DAD, duplicate address detection. So we know that if you assign an address, yes, Dorothy, you raised your hand. Do you have a question?
Hello?
Yes, please go ahead.
Can you still explain on that about multicast? The FF02 ::, there's something you were explaining. I didn't get it well.
Okay. So
yes.
let me just repeat it.
Yes.
So with IPv6, we have 3 types of packets. We have unicast. With unicast, we have global unicast and link local unicast. We know unicast is 1-to-1. Then we have multicast. With multicast, it's only a group. A group of devices in your network will process that packet if that particular interface belongs to that group. Then the last type of packets in IPv6 networks is what we call anycast. Anycast, where multiple interfaces can be referenced using the same IPv6 address. And therefore, whichever interface that will serve you is the one that is closest to you, which is determined by the routing protocol, the cost value of the routing protocol that you're using. So right now, we're talking about multicast. With multicast address, they have been reserved on the range of FF02, the entire of that. So the entire of that particular address range is actually reserved as the multicast group. Now, a number of multicast groups, a number of multicast addresses are already in use. For example, one of them is FF02:1. This one is used to reference all nodes. All nodes simply means all interfaces that have been connected to that network segment. So that's one of them that has been used. The other one is 0022. This group is for all routers. So all routers, any router interface that you configure with an IPv6 address will be added to this multicast group. We have also others, for example, FF02, 5, that is used for all OSPF routers. Other multicast also like FF02, 6, that is used to reference all DR routers. So these are simply like WhatsApp groups. So multicast is like WhatsApp group. So once you added to that particular group, if any packet is destined to this address, then you're going to process it. if you've been added to that particular group. So I don't know whether you've understood a little bit more about multicast. So in IPv6,
Yes.
we do not have broadcast. We do not have broadcast packet, as I explained during the theory class. Okay, so it is important to also mention that after you've assigned an interface, an IP address, DAD has to happen. ND here is for network discovery, and DAD is for duplicate address detection. And we actually know how it happens. So you can actually see that we sent out, we did one DAD attempt. So before DAD is performed, that address is called a tentative address, and the interface cannot use it. So if no one replies to the DAD, remember this is just like gratuitous ARP when it comes to IPv4. So if no one replies, I can use the IPv6 address. If someone replies to the neighbor solicitation, so you'll send a neighbor solicitation asking, hey, who is using this IPv6 address? So if no one replies, then you can go ahead and use it. If someone replies within your network segment, you know that that address is being used by someone else, and therefore you drop it. So that is what we call a DAD. Okay, so I think now we can go back to the lab guide and now look at step 3, which is configuring OSPF. So we want to configure OSPF version 3. We want to configure OSPF version 3 so that we can enable the router loopback interfaces to be accessible. So for example, now if I ping if I do ping I want to ping the loopback interface. I want to ping the loopback interface, for example, on R3. Okay, so let me just do that. So from R1, ping IPv6, ping IPv6, then I can enter the address 001 3 :C. So see, if I ping the loopback on R3, it should fail because we have not configured OSPF for any routing protocol. So it cannot really work. Okay. What if we ping the directly connected interface? So ping IPv6, then we try FE803. Then here we have to specify an interface, the outgoing interface for this particular packet. So to do that, we have to enter the name and the number of the interface. So let's see. Just a moment. I was forgetting that -I. So -I, outgoing interface name for link local address. So that is what I'm using. I'm using the name. So G0/0/0. So you see, if I ping router 3 from router 1 on the link local interface, the ping will be successful. But if I ping the loopback on R3, it's not going to be successful. So I think we are already past that. So now we want to configure OSPF v3 in order to enable these routers to share their routes. So how do we do that? Again, we have to be on system view. So just like OSPF version 2, so OSPF, so you have to do OSPF v3, then the process number. Now let me do a question mark. So with OSPF version 3, you can't do the router ID on the same line. So you go into OSPF v3 process 1, then you can specify the router ID. So router ID 1.1.1.1 for router 1. Okay, so after that, we can quit. Then we have to go to the interface, the particular interface that we want to advertise its network. So we go to 0/0/0. We go to that interface, then do the command OSPF version 3 process 1 area 0. So we are simply saying that we are adding this interface to OSPF version 3 process 1, and it's on area 0, like that. So then again, we go to the loopback interface. So we can do loop 0. Then we do the same command. So OSPF v3 process 1 area 0, like that. So with that, we are done with R1. Now we can do the same thing on R2. So on R2, we go and do OSPF v3 process 1. Then we give it a router ID 2.2.2. Then you can quit. Then you go to the interface 0/0. Then we do OSPF v3 process 1 area 0. Then you go into the loopback. We also do OSPF v3 process 1 area 0, like that. Okay, so once you've done that, we also do the same on R3. So here we do OSPF v3 process 1. We give it a router ID 3.3.3. We quit. We go into interface 0/0/0. We do OSPF v3 process 1 area 0. Then we go into the loopback 0 and also do OSPF v3 area 0. Okay. So once we've done that, we can use the command display OSPF peer on whichever router to see. So display, this time we do OSPF v3 because we are looking at the version 3. We want to see the version 3 neighbor relationship. So when you do that from R3, we can see that it has formed a neighbor relationship with R1 and R2. We can see that R1 is the DR and R2 is the BDR. So that particular command is able to show us exactly that. If we do the same command from R1, so display OSPF v3 peer, we should see that R3 is a DR other, and you can also see the interface via which it is forming this OSPF neighbor relationship. Okay. So now we should be able to ping. We should be able now to ping the. We should be able to ping the loopback. Let me see if I can get that back. So we should be able to ping the loopback on. So ping IPv6. So we want to ping the loopback on R3 from R1. So :C. So if we do that, request timeout. Why? Okay. Wow. This should actually be working unless here display IPv6 interface brief. Did I configure the correct? Oh, I did. I configured the wrong address on loopback 0. I was supposed to configure 2001, and I configured this. So sorry about that. Let me just redo that. So int loop 0. So IPv6 address supposed to be 2001 3:C 64. Display this. Okay, so I can just undo. I can undo IPv6 address FE803 link local. So display this. Good. So I've just removed this so that we just remain with this particular address. So now we have that particular address. You can see that it's also operating on OSPF v3 on this particular area 0. Okay, so now if we do the ping, it should work from R1. Good. So that has been successful, and for example, let me just see display IPv6 routing table protocol OSPF v3. Okay, so we can see that indeed on the routing table of R1, we have the entry for the network for this particular network on R3, and we can see the next hop. We also have an entry to this particular network on R2, and we can see if we want to go there, our next hop is this link local address that is interconnecting us with R2. So that is how you view the content of the IPv6 routing table. So display IPv6 routing table. If you want to see entries for a particular protocol, you go ahead and do protocol, then you specify OSPF v3. Okay, so now let's go back to our guide. So we've already done that on peer. We have what is called the graceful restart feature. So in case our router 1 was not the DR, we could have used the graceful restart feature to restart the OSPF v3 process 1 in order to ensure that we have elections again. If we have elections again, and then obviously R1 will be the DR, will be elected as the DR. Okay, so let's go to step 4. So on step 4, we are supposed to configure DHCP to distribute IPv6 addresses. As we learned in the theory class, with IPv6, end devices can be able to generate their own IPv6 addresses using Slack and EUI. But disadvantages of that: cannot provide configuration parameters. It makes it easy for you to manage your network because it does not record who has what address. So it becomes quite a challenge. That's why you need a DHCP version 6 server actually. Okay, so let's go ahead and look at these commands. So in order to configure a DHCP v6 on R2, so enable the DHCP v6 server function R2 so that devices can be assigned IPv6 addresses using DHCP v6. So here we are going to do DHCP enable to enable DHCP v6. Then we go ahead and choose DUDLL. So we know DHCP unique identifier. Formats, we have LL, LLT, and EN, and explained their functionalities in the theory class. So after you've chosen that, they're going to ask you whether you really want to do it. Yes. Then we create an IPv6 pool. We call it pool 1. Then we give it the prefix, the IPv6 prefix. So the prefix we're going to give is this one here, /64. So the prefix is 64 bits long. Then we also specify other configuration parameters like the IPv6 address of the DNS server, and we exclude this particular first address on this particular address range. So we exclude this particular address using that command. Okay, so let's go ahead and do that on R2. Let's do these commands first, and then we can look at the next one. So we want to configure R2 here. So we go to System View. Then we do the command DHCP enable, like that. So it will take a few seconds. Then we do DHCP v6 version 6 dude. You can do question mark. Now, Huawei routers do not support EN. It only uses dude link layer and dude link layer and timestamp. So it does not support the enterprise, the link layer and enterprise. So those are the only two formats that you can choose from. So you want to choose LL for this particular lab. So do you want to do it unique identifier? The DHCP unique identifier should be globally unique and stable. So sure to change it. I type try, then enter. So now let's create the DHCP v6 pool. So DHCP v6 pool, the name of the pool, pool 1. We give it the address prefix. So we want the address prefix to be 2001 colon face double colon 64. Wrong parameter. Okay, let me see whether I can do slash here. Okay, so I think I was supposed to do the prefix with the slash notation. So make sure to do that. Then we specify the DNS server IPv6 address. So 001 44E 5300 double colon 1. Then we also exclude, so excluded address. We exclude the very first address on this address range. Maybe we've assigned it to our gateway, so we exclude it like that. So quit. Now, after creating the pool, you now have to enable the interface that is connecting to that network segment to be able to assign IPv6 addresses. So in this case on R2, it is the interface gigabit Ethernet 0/0/0. So we want to bind that particular pool to that interface. So int 000. Then we do IPv6. We give it another IPv6 address. So 001 face 1. So we are giving it that particular, the very first address that we excluded. So we are giving it that. Then we do DHCP v6, DHCP v6 server. So pool 1, the name of the pool that we created, like that. So we've configured R1, R2 as a DHCP server. So the next step should be to enable the DHCP client function on R1 and R3 so that devices can obtain IPv6 address using DHCP v6. So to do that, again, we have to enable on system view DHCP. Then we choose the DUD format that we want to use. Then we go to that interface that is connecting to the same segment as our DHCP server. And we use the command IPv6 address auto DHCP. So we want it to use DHCP to acquire an IPv6 address. Okay, so let's do exactly that. So we can begin with the R1. So we do DHCP enable, then we do DHCP v6. The DUD format we wanted to use is LL, yes. Then we go into the interface gigabit Ethernet 0/0/0. Then we use the command DHCP v6 server. No, this is not the server actually. DHCP v6, IPv6, sorry. IPv6 address auto DHCP, like that. So with that, we are done configuring R1. We also configure R3 as a DHCP client. So we enable DHCP, so DHCP enable, then DHCP v6 DUD LL. Then we go ahead and go into the interface gigabit Ethernet 0/0/0. Then we do IPv6 address auto DHCP. Enter. So you're simply telling that interface to ensure that they get an address via DHCP. So what's the next thing? So run the display DHCP pool command on R2 to check the information about the address pool that we created. So we can do that on R2. So quit display DHCP v6 pool. So we should be able to see the name of the pool as pool 1, the address prefix, the number of active normal clients. So we have those clients. We can also see the address, excluded address. So we've excluded this particular address. Whether we have any conflicts, 0. How many addresses are in use? 2 so far. We can also see that we have the DNS server address that will be issued out by this DHCP server. Okay, so we can now go ahead on R1 and confirm that indeed it has been assigned. It has been assigned an address. So we can do display IPv6 interface brief. Then we check this particular address, this particular interface, gigabit Ethernet 000. So let's do that on, let's do that on R1. So quit display IPv6 interface brief. Okay, so we can see that now this particular interface is no longer using the link local address. It's actually using the address that it has been assigned via DHCP. I'm sure if we do the same here, let me try this, display this. So here we cannot see. We can only see the command here, but we cannot see the DHCP address on this particular interface. So we have to quit and use the command display IPv6 interface brief. So if we do that, we can see that even though we've configured a link local address on that interface, the one that is being used is the one that has been assigned via DHCP. That one. Okay, so what else is remaining? So that is it about this lab, ladies and gentlemen. I hope you've been able to understand IPv6 better, OSPF v3, and DHCP version 6. Anyone with a question? Anyone with a question? Okay, asanteni sana.